A pollster wishes to estimate the number of left-handed people. How large a sample is needed in order to be 98% confident that the sample proportion will not differ from the true proportion by more than 6%. Previous study indicates the proportion of left-handed people is 9%. We got two different types of formulas when you're finding the sample size to estimate the proportion. And one of them is where p hat is given, and one of them where p hat is not given. Now, p hat is amount from a previous study, and you see it tells me a previous study indicates that the proportion is 9%. So this one is where p hat is known. So if they give you the amount from a previous study, we're going to use n is equal to p hat times 1 minus p hat times z alpha divided by 2 divided by e squared. Okay, well, they tell us that from the previous study it's 9%, so they're telling us p hat is 9%. And you always want that in decimal form, so I'll use 0.09. Now they also give us e. It says that the sample proportion will not differ from the true proportion by more than 6%. So that's our margin of error. And we want it in decimal form, so we'll use 0.06. And we want 98% confidence. Well, we have everything except for the critical z-score, so let's find that. If they tell you 98% confidence, we put 98% in the middle, and you split the remaining 2% between tails, because all this has to add up to 100%. Well, I put 1% here and 1% over here. Now this is our critical z-score, and we're going to use INV norm to find that. Now INV norm is always based upon the area of the left. The area of the left is the 0.01 and the 0.98, so you add those together, and that gives us 0.99. So let's see what that gives us. So I got second vars, choose INV norm, 0.99, enter. And I always want to take this two decimal places for purposes of online homework. So that round to 2.33. So now we have everything. So plug in p hat's 0.09. So I got 0.09 times 1 minus 0.09. Z was 2.33. Divided by E, which was 0.06, and then squared. So let's see, we got 0.09 times 1 minus 0.09. I'm putting that inside of parentheses. Times, and then 2.33 divided by 0.06, close parentheses, squared. And then press enter. Now we always want to round up no matter what our decimals are, so this goes to 124. And that'd be your answer.